See it, Parker?
Yeah, I guess I put this on the wrong side. It's supposed to be on this side.
So your slope is wrong. Okay. Hey guys, we're dealing with 5/8 today, parallel and perpendicular. And when we look at these lines that you just graphed, the letter A and D, or A and B here, okay, we got Brendan's up here. What do you notice about those lines? Annalise? They do intersect. And when we're looking at the point of intersection right here, this corner right here, what kind of angle is that? TT? That's a right angle. Everyone take the corner of another piece of paper and just slide it in there. Okay? It's a right angle. So if I take the corner of a piece of paper, it happens to hit that angle perfectly at 90 degrees. That's a right angle. That's a 90-degree angle. We call those types of lines, what do we call those? Yeah, they are lines. Good. Yes. They intersect. Nice work. There are two of them. Okay? Yeah. Yeah, those are perpendicular lines. And two lines intersect at a right angle. If you didn't know that, that's called perpendicular. Okay, you've probably heard the term before, but it might be something to add to your notes if you can't recall it. Those are perpendicular. I want you to tell your neighbor and talk to your neighbor and try to figure out why these lines are perpendicular. What makes those perpendicular? Focus on the equations. Look at your picture. Why are they perpendicular? You get about 1 minute to talk about it. Lines perpendicular. Oh, any guesses? Annalise? Yeah, the slope. So if we look at the slope, everything's flipped. Did anyone else notice that their slopes are flipped? Yeah, 2/5 becomes 5/2. They're not only flipped, what else is happening with those slopes? Okay.
One's a negative and the other one's not.
Yeah, one's a negative and the other one's not. So their signs are opposite, right? So when our slopes, like notice this slope has a negative slope and this one has a positive slope. That's the only way you can get those perpendicular lines is if you have one positive slope and one negative slope, or one zero slope and one undefined slope, I guess would work as well. But anytime the slopes are flipped and the signs are opposite, you get perpendicular lines. The other thing, I want everyone to take these two slopes, the 2/5. So take 2/5 and negative 5/2, and I want you to multiply those two things together. Okay, so multiply 2/5 by negative 5/2 on paper. You don't need a calculator for this. Okay? Multiply them together, please. Okay, when I multiply, you guys, we should be in the mode of cross-canceling now. 2 cancels 2. 5 cancels 5. Those just all become 1s. We have a positive times a negative, which is a negative. Negative 1 over 1, or negative 1. When the product of your slopes is negative 1, those are going to be perpendicular. That's another way to test that out. So you can think of it two ways. They're reciprocals. Reciprocal means that we flip it around. How many have heard the term reciprocal before? And they're inverses. Inverse means you change the sign. Okay? So they're inverse reciprocals. Okay? The sign changes and they're flipped. Okay. Everyone take a look at the other side, please. So those are perpendicular. All right. How many have a finished graph? Finished graph on those. Okay, this is what Brendan has. Maybe you check yours out. I haven't checked his, but he did pretty well on the front, so let's see. How many have ones that match for A and B? We didn't graph C and D, right? Okay, good. So we have a y-intercept of 5 and a slope of 1 over 3. Good. He's continued that out. And y-intercept of 1, a slope of 1 over 3. Fantastic. What do we notice about these lines? Yeah, they're parallel. And what makes them parallel? Jake, what do you think? What makes them parallel?
They're like the same, but they're just...
Yeah, they're like the exact same, but they're different levels. They're never going to cross. Yeah, and if we look at the equations, what takes a long time with graphs is you have to graph them. But if you can look at the equations and know something's parallel, that's beneficial. Notice the slopes are the same. If the slopes are the same, are the y-intercepts the same? No. Y-intercepts are different. If the y-intercepts were the same, they'd be the exact same line. Okay? But if the slopes are the same and the y-intercepts are different, then they're parallel. Okay? Parallel lines there. Parallel lines, by the way, they have no solutions, right? we'll end up getting to this next chapter, but when you have parallel lines, they never cross. And if they never cross, they never intersect, they never share a common point. That's kind of a little foreshadowing for next chapter. Okay. How many of you knew this stuff already? How many kind of recall it from last year? A bit of review. Okay, and some of you it's brand new for. All right? Well, here's what I want to do. I want to summarize this. So right now, I want you to complete this statement in your notes. Okay? Two lines are parallel, then they have blank blank slope. All right? We're going to do that statement, then we'll have another one. If two lines are parallel, then what do we know about their slopes? Got a couple? Tell your neighbor what you put.
The same. I said before you.
All right. Chelsea, what do you got? Yeah, they have the same slope, right? So when we're looking at this, rather than having to graph them every time, which takes a long time, if we can compare the slopes, then we know they're the same. We know they're parallel. All right? What's the next question going to be? What's it going to have to do with? Yeah, it's going to have perpendicular lines. Okay? Perpendicular lines. If two lines are perpendicular, then their slopes are what? And to help you out, you can reference these slopes here. I'm going to let you guys fill it out real quick. You share with your neighbor. The wording is kind of weird on it, so the way we say it. So what's one thing we know?
They're right angles.
Okay, they intersect at right angles. We know that. What do we know about the slopes? Annalise? Oh, you remember the terms, man. Inverse. What's inverse mean? Yeah, the signs are flipped. Okay, so you may, if you're using this terminology, you may want to make a note to yourself. That means the signs are flipped, or one's positive, one's negative. May even be a better way of saying that. Okay, one is positive, one is negative. Okay, and then reciprocals. What's reciprocal mean? Toki, what's reciprocal mean? You know? You want to take a guess? So remember what we did with our slopes here. Oh, I don't have that. Where did I put that page? So we flipped the signs, right? One's positive, one's negative. What else did we do to the fractions?
You flip the numerator and denominator.
Yeah, you flip the numerator and denominator. Remember, reciprocal just means you turn them upside down. You turn the fractions upside down. Okay? So you flip the fraction. Now remember, we had one way of testing that. Tell your neighbor what was that way that we had to test it. What did we do? What was the other test we did? Don't tell me. Tell him. No? We multiply these two things together. Annalise? -1. Cole, what were you going to say? -1. Remember, when we multiply, we just went through 2/5 times -5/2. That gives us -1. So that's the other test. All right, we're going to try some of these. I want you to take a look at problems 1 and 2 here. I want you to find a slope of a line that's parallel and perpendicular to each of those. Okay? Just try 1 and 2 right now. Work with your partner. You guys get about 2 minutes on. For number 1. Come on, man. Dude. Take a shot. No one else wants to. Okay. Well, at least we'll get parallel down. You got perpendicular? Perpendicular for number 2. Good job, eh? Getting some good ones. All right. Hey, let's let's check them out. Thank you, guys. So, number 1, a slope that's parallel to y equals 3x minus 8. How many got 3? Has to be the same, right? Yeah, so 3. And we're just looking for slope. So I saw that some of you put equations. We don't need an equation. We just need the slope. And really, we never include the x, right? That's not part of our slope. So just the number 3. Okay? Perpendicular, 1/3. That's really close. What are we missing on the perpendicular? Boy, Cole, what do you got? Yeah, it has to be negative, right? We have to flip the sign. But whoever did this, good job. You got the reciprocal. And the hard part there is, remember, there's a 1 there. So when you flip it, it becomes 1/3. So it's negative 1/3 is perpendicular. Okay, number 2, parallel. 2/3. Everyone get that? Have to be the same. Perpendicular, we flip it. Chelsea's got negative 3/2. How many got negative 3/2 there? Good. So what's different on number 5? What makes that one more complex? Annalise? Yeah, we've got stuff with the y. We have stuff with the x. We don't really know. We can't easily pick out the slope, right? Now yesterday we spent a lot of time working on this so we get these in slope-intercept form. Okay, that should be a quick process now. Okay, everyone put that into slope-intercept form. Okay. What do we do first? Number 5. Okay, Brendan, what do you got? What do we do first? Subtract 9x. Let's get rid of the 9x. Okay? So, Bobby, what's that give me on this side?
3y.
3y. Mackenzie, what's it give me on this side? Almost. So we got this. You guys stay with me. Negative 9x. What kind of 6 is that? Positive. We can't put them together, so negative 9x plus 6. Jaden, what do we do next to get rid of that? Or to get that y by itself? Nope, 6 is here. We want to get y by itself. Divide by? Divide by 3, yeah. Good job, Jaden's groupies, helping around. Okay, divide by 3. These cancel. We're left with y. Negative 9 divided by 3 is? Everyone says negative 3, or almost everyone. And 6 divided by 3 is? 2. What's our slope? Everyone, what's our slope? Negative 3. So if it's parallel, that's the symbol for parallel. Parallel is? What's slope have to be? Dude, one of us had it. Who else? Patrick, what do you got? Parallel? Negative 3. Toki, you agree?
Yeah.
Perpendicular. Perpendicular, upside down T. Okay. Jake, what do you think? Perpendicular.
I don't know.
It was negative. It has to be now what? Positive. Okay. And the fraction was negative 3 over 1, so it's positive. What?
Positive 3 over 1.
It's not positive. Huh?
I don't know.
Okay. So let's go back to your notes real quick. Okay. How many got it? Think you have it? Help him out. What is it? Yeah. 1 over 3. So what was Jake do? What did he forget? He had the sign flipped. Yeah. There's a 1 underneath the 3, and then we have to flip it. So Jake, you had the positive right. We just got to flip it over then. Okay. So make a note of it. So if you guys, as I'm asking these questions, if you're like, oh man, please don't call on me. I don't know. Or I call on you and you don't know, make a note of it. Keegan, you get all that?
Yeah.
You look like you're tugging at your eye like you're not sure. Okay.
I got it all.
You sure?
Yeah.
All?
Yeah.
You know the word all has parallel lines in it?
Yeah.
That was a pretty good.
Depends on who's
Well
writing
done.
it.
Huh. Nice job. Okay. All right, take a look at your assignment, please.
Depends on who's writing all.
A-double-L. All. Okay. Read through the directions. Example 1, find the slope of the line parallel to the graph of each. So we're finding the slope for parallel. Example 2, or down here, 13 through 21. Kyla, will you read those directions, please? Good. So what's the difference between example 1 and 13 through 21? Annalise?
In 13 through 21, you write in equations.
Yeah, in 13 through 21, you have to write an equation. So if I'm looking at this and I'm going, well, I need to write an equation that's parallel, what are the two things you need for an equation? Ayla, two things we need for an equation. Think back to what we've been doing. Help her out. Good, yeah, we need M and we need B. If the line's parallel, do we know the slope? Yeah, the slope is this. Now we have to find B, and we use y equals mx plus b to do that. Right? We know an x and a y value. We know our slope. Use your equation to find your b value. Okay? All right, let's take a look at the back real quick. Write an equation of a line in slope-intercept form that contains the given point and is perpendicular. And once again, you need to know m and b. Okay? You're going to use that slope to help you find that. Remember, perpendicular means your inverse reciprocals. And then 28, 29, and 30, we have to find one that goes through this point and is perpendicular to this line. Okay, so there's a couple ways you can do it. I mean, you could actually use the picture, or you can think of it like this again. Find m and b. Okay? If you know m, use that and a point to find what b is. It has to go through this point and be perpendicular. Now I'm just kind of sketching in a line there, but that's what they're asking. What's the equation of that line that would be perpendicular? Okay. Go at it. Make sure you're asking questions. Okay?